This is a key to sample problems that you will probably see on homework, quiz, or a test. So let's look at number 16. So number 16, it says find the distance and midpoint of a segment containing the following endpoints. So the endpoints of the segment are negative 3, 4, and 7, negative 2. So if you looked at this, and it's not necessary to do this, but if you did look at this in terms of that segment and how it's situated in this coordinate plane, let's go ahead and graph this segment. So you have the point negative 3, 4. So negative 3, you go to the left 3 units, you start at the origin, you go to the left 3 units. Remember, I'm plotting the point negative 3, 4. So we go to the left 3 units, 1, 2, 3, and then we go up 4. Since 4 is positive, we go up 4. 1, 2, 3, 4. So there's the endpoint, negative 3, 4. Remember, this is a segment, not a line. The other point that we need to look at is negative 7, 7, negative 2. 7, negative 2, start at the origin, you go to the right 7 since 7 is positive, and then go down 2 since 2 is negative, and so there's the other end point. So that end point is 7, negative 2. So if you graph that segment, now remember it's a segment, not a line or a ray, it's a segment, so don't draw any arrows. So that's a segment with those two endpoints. And what they want you to do is they want you to find the distance of that segment and the midpoint of that segment. So the distance of the segment, we're going to go ahead and use the distance formula. So the distance formula, if you remember the lessons, if you were to draw a right triangle, that distance formula comes about from the idea that you can draw a right triangle and you could use Pythagorean's theorem to find the hypotenuse. So that segment right here, if you draw a right triangle, would be the hypotenuse. All right, but we're going to go ahead and use the distance formula. So remember the distance formula between 2 points on a segment. So let's see, the distance formula. So the distance formula, remember, is defined to be this, the square root of. So basically, you're going to subtract your x coordinates from each other. So you're going to say x2 minus x1 squared. You're always going to square it. Plus, and then you're going to subtract the y coordinates from each other. y2 minus y1, whatever that difference is, you're going to square it. So notice the sum of the differences of the squares are under the square root symbol. So that's your radicand. So you're taking the square root of that. All right, so in this case, I'm going to go ahead and rewrite this since I drew over right under it. So these are my points. And it's a good idea to label those points. So if this right here is considered your first point and this is a second point, which it does not matter, I'm going to call this the x coordinate of my first point. So notice x sub 1. This will be the y coordinate of my first point. So y sub 1. So the ones here are subscripts. For this is the second point. So I'm going to call this x sub 2, y sub 2. I'm going to take these values, I'm going to substitute to the formula. So the distance will be the square root of, and then you just substitute. So x2 is, in this case, 7. Subtract, remember you're subtracting, subtract x1, which is a negative 3. And then I'm going to square that. Make sure you extend that radical symbol. Plus, and then do the same thing with the y's. y2, which is negative 2. Subtract y1, which is 4, and I'm going to square that. Okay. Now, remember, always simplify the parentheses, the expression that's inside the parentheses. So we know that 7 subtract a negative 3 means 7 plus 3, right? So it'll be the square root of 10 squared. Put that in parentheses and square it. Plus a negative 2 and a negative 4 is a negative 6, and that's also being squared. So that's going to equal the square root of 10 squared is 100 plus negative 6 squared is 36. Now remember, just like you talked about when you dealt with the quadratic formula, whenever you're squaring something that's inside the parentheses like this, whether it's negative or positive, whenever you square it, it's always going to be positive. So when you square that negative 6 squared, when you said negative 6 squared, you need to make sure you end up with a positive 36 and not a negative 36. And so therefore we get the square root of 136. All right, now the direction says simplify radicals if possible, and I didn't have to tell you that. It's always understood that you should, you shall simplify radicals. So what we got to do is determine what perfect square other than 1 will go into 136. So the next perfect square other than 1 is 4. So let's see if 4 goes into 136. So 136 divided by 4 equals 34, and it does. All right. Now look at 34. So is there a perfect square other than 1 that goes into 34? Well, let's try 34 divided by, since we know that 34 is 2, now 2 is not a perfect square, but I want to use it. So 34 divided by 2 is 17. So 34 is 2 times 17, and none of those, 17 is prime, 2 is 2 is prime, so you can't do anything else to that. Okay, so so the only perfect square besides one that goes into 136 is 4. So I'm going to write this as the square root of 4 times the square root of, I think it was 34 we said, and the square root of 4 is 2, so I get 2 square root of 34. And so there's the distance. So the distance equals 2 square root of 34. All right, so that's the distance of this segment. And they didn't ask you to do this, unless they ask you to do this, then don't do what I'm about to do. But if you wanted to round this to the nearest tenth, just to see the length of this, you would say 2 times the square root of 34. So make sure you use your square root button. So that's right above the x squared. So I have to go to second x squared. All right, like this. So you notice it inputs that radical symbol right here. And then 34, close the parentheses, press equal. So this is about 11.7 units long, whatever the units are. 11.7. Okay? All right, but always simplify the radicals and leave this as an exact answer. Now the midpoint, so remember the midpoint of a segment is the point that's in the middle of that segment. So somewhere around here is the midpoint. So around this area. So it's the middle of that segment, the midpoint, the middle of that segment. Don't look at that and think that, oh, it's going to be 2, 1. You don't know that for sure, because remember I drew this by hand. All right, so you need to do this mathematically. So the formula for midpoint is this. So the formula for midpoint, so remember it's the point in the middle. So you're going to add your x coordinates together, divide by 2. So always divide by 2 because you're looking at the midpoint, the point in the middle, the point that's the halfway mark. And then you add the y coordinates together. Oops. So y1 plus y2 divided by 2. Now remember, the midpoint's a point, so you got to put that in parentheses with a comma. Now don't confuse distance and midpoint. So the distance, I had to subtract the x coordinates from each other and subtract the y coordinates from each other. Because remember when you looked at this in terms of a right triangle, and use Pythagorean's theorem, this leg and this leg, you had to subtract the coordinates to get that length. Whereas with a midpoint, you add your x coordinates together and divide that sum by 2. Add your y coordinates together and divide that sum by 2. And so therefore, when I do that, we know that x1 is -3. So we're going to say -3 plus x2, which is 7, divided by 2, comma, and then y1, which is 4, plus y2, which is -2, divided by 2. All right, and so when I add -3 plus 4, when I simplify that, that's going to be 4 halves, put that in parentheses, comma, and then 4 and -2 is 2 halves, which is going to equal 4 divided by 2 is 2, 2 divided by 2 is 1. So the point that's in the middle of that segment, so the midpoint of that segment is indeed 2, 1. So that right here is the midpoint. Okay? All right, but you had to show the distance, you had to show the work for the distance and the work for the midpoint. All right, so that is number 16. All right, now number 17 This time you're dealing with the line, and you want to find the slope of the line that contains those 2 points. So if you look at the graph that contains those 2 points, we have this. So we have negative 8, 7. So negative 8, 7. So negative 8, 7. So always use the x coordinate first and then y second. So I store the origin. Since 8 is negative, I go to the left 8. And since 7 is positive, I go up 7. So there's the point right here, negative 8, 7. The other point on that line is negative 3, negative 2. So negative 3, I go to the left 3, and then down 2 since y is negative. So there's the other point on that line. And if I graph it, remember it's a line, so I'm going to draw the line and then use arrows. So there's my line. And you got to remember a couple of things. So as you go from left to right, notice that your line is falling. Well, we know that if the line is falling, the slope is negative. So the slope is negative. So when I do my work, I better make sure I get a negative slope. If the line had risen like this, so let's say the line had done that, then the slope would be positive. So the line is rising. The other thing you learned is that if the line is horizontal, the slope is 0. You also learned that if the line is vertical, there is no slope. So you say no slope. No slope, or you can say the slope is undefined. Okay? All right. But in our case, the line is falling as you go from left to right, so the slope is negative. So when I do this work, I better get a negative slope. All right, now the formula for finding the slope, so again, we're going to label these x1, y1, x2, y2. And the formula for slope is this. Remember, slope is rise over run, and the rise is the change in y. So remember, rise, if you think about your axes, the axis that rises is the vertical axis is the y-axis. The run, the horizontal axis, is the x-axis. So we do change in y divided by change in x. So delta y, delta x. And the formula is actually this. You're going to subtract your y coordinates. So change means to subtract, change in y means subtract y coordinates. So you're going to say y2 minus y1. Now the order matters for slope. So if I use y2 first, I must use x2 first in the change in x. So x2 minus x1. So the subscripts right here must match up. y2, x2, y1, x1. And then you just substitute, so we get the slope equals y2 is a negative 2, subtract y1, which is a negative 7, divided by x2, which is a negative 3, subtract x1, which is 8. The numerator, negative 2 subtracted negative 7, means negative 2 plus 7, divided by negative 3 subtract 8 means the same thing as negative 3 plus a negative 8. Negative 2 plus 7 is 5. Negative 3 plus 8 is negative 11. So my slope is a negative 5/11. And it's negative, and that's what we said it had to be. All right, so that was 17. Okay, now 18. So let's look at 18. Okay, so 18 asks this. So 18 says, graph the following linear equation using intercepts. Indicate the coordinates of the intercepts on the graph. All right, so a couple things you got to remember. When we talk about intercepts, we're talking about the x and the y intercept. So remember what we mean by intercepts. So by intercepts, let me kind of just do this one. So by intercept, if this is our line right here, if this is our line, let me just draw it like this. So if this is our line, this line crosses the y-axis here. So this is what we call the y-intercept. And the line crosses the x-axis here, so that's the x-intercept. Now when finding the intercepts, when you're given an equation in terms of x and y, It's very easy to do. To find the y-intercept, you're going to now remember, wherever you are on this y-axis, the x-coordinate is always 0. So if you're going to find the y-intercept, you just let x equal 0. And if you're going to find the x-intercept, so no matter where you are on this x-axis, the y-coordinate is always 0. So if I want to find the x-intercept, you let y equal 0. Okay? So that's the idea you're going to use here. So in number 18, you're going to say to find the x-intercept, I'm going to let y equals 0. So in place of y, you're going to substitute 0. So when I substitute 0, I get 4x minus 3 times 0 equals 12. Well, 3 times 0 is 0, so this is just 4x on this side, so 4x equals 12. And when I divide both sides by 4 to get x by itself, I found the x-intercept. So the x-intercept happens to be 12 divided by 4 is 3. So that's where the graph is going to cross the x-axis. So on the x-axis, my graph's going to cross the x-axis at this point right here. Then I find the y-intercept. All right, so when I find the y-intercept, I'm going to let x equal 0 this time. So in place of x, I'm going to substitute 0. So I get 4 times 0 minus 3y equal 12. Well, 4 times 0 is 0, so that's 0 right here. 0 and a negative 3y is a negative 3y equal 12. And then to get y by itself, you can divide both sides by negative 3. The negative 3's divide out, you get 1. 1 times y is y. And this time the y-intercept is 12 divided by negative 3, which is a negative 4. So what I just found is that the line is going to cross the y-axis at negative 4. And so I'm going to draw my line. Draw your line just like this. And there's the line. Those are my intercepts, the x-intercept, y-intercept. But remember the directions. The direction says indicate the coordinates of the intercept on the graph. Okay, so that's important. Always make sure you follow directions. So I want you to tell me what those coordinates are. So this is the x-intercept 3. So that means that the coordinates, meaning what's the x, what's the y. So the x is 3 and the y is 0. Over here, the y-intercept, then that means the x is 0 and the y-intercept is negative 4. So that's what I mean by indicating the coordinates. So that's important that you know that. And so that's it. So there's the graph. All right, so that was number 18. All right, number 19, we have this for number 19. So number 19, it says, graph the following linear equation by finding at least 2 points on the graph, and then find the points on the line whose coordinates are integers. All right, so the direction says you want to graph this by finding at least 2 points. Now remember, a line, if you think about the line we just drew right here, a line has an infinite number of points, right? So a line has an infinite number of points. We found that line by just finding 2 points here, the x and y intercept. What I want you to do here, though, is to find 2 points in that line, which contains an infinite number of points. But here's what I need for you to do. The points I want you to use, I want those coordinates to be integers. So meaning no fractions, no decimals. All right. So you're gonna have to. So I'm restricting you to certain numbers that you can use. So those coordinates have to be integers. All right. So you're gonna have to pick numbers that are strategic to what I'm asking you to do. So if I'm asking you to make sure that those coordinates are integers, then the way to do this is this. So you can draw a t-table, just like we did. And I want you to notice, and you always have to look at the denominator. All right, so if I want the x and the y coordinate to be integers, meaning no fractions, no decimals, then I need to choose values of x for which are divisible by 5, which 5 is a factor. So all you do is just pick numbers that 5 go into. For example, 0. If x is 0, I get y equals negative 3/5 times 0 plus 4. And so 0 is an integer, right? 0 is an integer. Negative 3 fifths times 0 is 0. 0 plus 4 is 4, and 4 is also an integer. So there's one of my points. The other you might want to use is 5. 5 is divisible by 5. So if x is 5, I get y equals negative 3 fifths times 5 plus 4. The 5's divide out, and negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. So there's another point. So there's an infinite number of points you can give me here as long as the x coordinates are integers and the y coordinates are integers. For example, another one would be negative 5. So any x value that's divisible by 5. So 5, negative 5, 10, negative 10, 15, negative 15, and so on, right? So on. So remember, all I want is 2, so I'm just going to stop here. You could use, I'm sorry, you could use just these two, but I'm going to do one more, just do a negative. So if x is negative 5, I get y equals negative 3 fifths times negative 5 plus 4. Well, the 5 goes to 5 one time, 5 goes to negative 5 negative 1 times. So a negative 3 times a negative 1 is a positive 3, and 3 plus 4 is 7. So there's the other point. All right, and so what most students will do is they'll do 3 points because you could easily mess up with 2 points. Whereas if you do 3, then all 3 points better lie in that same line. So if you do 3 points and 2 are here and then 1's here, then you have an error somewhere. All right, so all 3 points must be collinear. They have to lie on the same line. So it's always a good idea to use 3 points. In fact, the directions may tell you on a test to find at least 3 points instead of 2. Okay. All right, so those are integers, and so I'm good to graph. So let's go ahead and graph this. And so when I graph this, I have, let's see, 0, 4. So remember 0, 4, the x coordinate 0, the y coordinate's 4, so that's on the y-axis. 5, 1. 5, I go to the right, 1 up. Now remember, if you're doing this correctly, if you do this correctly, those points should be collinear. They should all lie in the same line. And then negative 5, 7. So negative 5, 7, go to left 5, and then up 7 is right here. And it looks like they're collinear, so I'm just going to draw the line going through those 3 points. And when I do that, make sure you draw your arrow. I get this. All right, so there's the line. Now, the directions will probably say this. Make sure you label the points. So if it says label the points, make sure you understand what that means. That means just don't put a little dot there. I want you to tell me what those coordinates are. All right, so indicate the coordinates. Indicate the coordinates. All right, so this coordinate right here is negative 5, 7, just like this. This coordinate here is 0, 4, and then this coordinate here is 5, 1. And that's it. So there's the graph. Not difficult at all. All right, and then finally number 20. Number 20, it says graph the following linear equation by finding at least 2 points. Now on a test, it will probably say 3. So I'm going to go ahead and put 3 right here. By finding at least 3 points on the graph. Find points on the line whose coordinates are integers, just like the previous problem. Now what makes this one right here a little bit more difficult to deal with versus that one is that y was already by itself. So if y is by itself, then finding 3 points on that line becomes very easy. All right. So remember, and this is in a future lesson that you learned, but when you get y by itself, that's called slope-intercept form. So here's the slope, here's the y-intercept. So 4 is the y-intercept, and it kind of makes sense, right? Because notice where the graph crosses the y-axis, at 4. All right, but whenever it's in slope-intercept form, you have y equals mx plus b. Now, the idea of the slope-intercept form is in a later lesson. So when you do this problem here, this one, they really wanted to use a t-table rather than using slope-intercept form because you have to know different approaches. So use a t-table. In another future assignment, you're going to be asked to find the slope and the y-intercept. So what you want to do here is to get y by itself. All right, so let's go ahead and first solve for y. So first, solve for y. All right, so I'm going to rewrite this over. 2x plus 3y equal 15. So I'm going to solve for y. I want to bring this term to the other side. So I want to bring that to the other side. So I'm going to subtract 2x from both sides. And when I do that and I combine like terms, the 2x's here add up to be 0. 2x minus 2x is 0. So that's 0. 0 plus 3y is 3y equal, and I'm going to put the variable term first. So it'll be negative 2x plus 15. And then I'm going to divide both sides by 3 to get y by itself, just like this. What you do to one side, you do to the other. 3 divided by 3 is 1. 1 times y is y. Now on this side, you want to write this as two separate fractions so it looks just like the previous problem where you have two different terms. You have this term and the constant. So go ahead and do the same thing here. So you'll say negative 2x divided by 3, so negative 2/3 x. And then a positive 15 divided by 3 is a positive 5. All right, so now this right here looks just like the previous problem. Okay? And so therefore you can use a t-table. And so let's go and use a t-table and remember the directions. The directions will say, I want you to use values of x and y that are integers. So whenever you get y by itself, the easiest number to use for x that's an integer is 0. And remember, by the way, whenever you let x equal 0, what you're actually finding whenever you let x equal 0 is the y-intercept. All right, so when x is 0, I get this. I get y equals negative 2/3 times 0 plus 5. Negative 2/3 times 0 is 0. 0 plus 5 is 5. So I found one of my points. I need two more because I'm going to say 3 points. So what you want to do now is this. Notice this, the slope is a fraction. So the coefficient of x is a fraction. So I want you to use values for x that are divisible by the denominator. So 3, negative 3. That's the way I would do this. 3 and its opposite. Some others would be, which if you want to do some others, you can. 6, negative 6. 9, negative 9. 12, negative 12, and so on. Okay? So you want x to be a value, you want x to be a number, a real number, an integer, by the way, an integer that's divisible by 3. So when x is 3, I get this. I get y equals negative 2/3 times 3 plus 5. That's a 3 here. 2/3 times 3. 3 into 3 is 1. 3 into 3 is 1. A negative 2 times 1 is a negative 2. Negative 2 plus 5 is a positive 3. So I get the point 33. Let's do the next one. Y equal negative 2/3 times negative 3 plus 5. 3 into 3 is 1. 3 into negative 3 is a negative 1. Negative 2 times a negative 1 is a positive 2. 2 plus 5 is 7. Okay? And then you just go ahead and plot those 3 points. So 0, 5, x is 0, y is 5. So there's your y-intercept. Label the point. Don't forget to do that. 3, 3. You go to the right 3, up 3. Just like this. 3, 3. And then negative 3, 7. Negative 3, you go to the left 3, and then up 7. And that's here. And remember, if you're doing this correctly, all those 3 points should lie in the same line. And in other words, they should be collinear. And they are. And that's it. There's the graph. Okay? All right, and so that's all you do. So make sure you understand the directions. All right? Understand the directions. I wanted you to use those 3 points. I wanted you to make sure that the coordinates you were using for the x and y were integers, so no fractions, no decimals. So what you had to do first was get y by itself. So make sure you know how to given a linear equation where you have two variables, you know how to solve for y. And that's it. And oh, and by the way, so the value of x that you use here will be an integer that's divisible by the denominator. In this case, is 3. So the value of x has to be multiples of 3. 0, 3, -3, 6, -6, 9, -9, and so on. All right, so that is it. So that is the key to some problems similar to what you will probably see on a test or a quiz or worksheets.